Good afternoon and welcome to our next webinar, the from text to value, pairing text analytics and generative AI. Joining us today, with myself, but along with Tom Reamy, Chief Knowledge Architect at the CAPS Group, and Imran Chowdhury, our Head Architect for AI in Healthcare and Life Sciences. 2023 was definitely the year of AI hype. There were a lot of expectations, some probably unfounded, towards what AI could do in its current shape and form. But businesses are now looking at, in this year, AI practically. So they're looking at where they know that there's constraints with AI, where there is problems, shall we say, within the platforms themselves, kind of fundamental things that you can't get away from. But outside of that, how can they practically apply that within their business and get value from that? This is, and I've written about this in a piece that's coming up, but it's kind of overcoming that digital transformation dead end. It's looking at AI to address a use case, deliver value from that use case to your business, rather than looking at it holistically, rather than saying, oh, we're going to use everything with Gen AI and it's all going to be AI enabled and things like that. Whilst an AI first strategy is, I think, appropriate, I think that it's the AI first, how do I deliver value quickly? How do I show productivity improvements in my business? And there are some legitimate use cases right now that even some of our customers are developing in their business, that is using some of the more advanced features in our platform. Now, organizations, like we said, aren't just talking about generative AI. They're investing time, money, and resources to move it forward and drive, and this is the important thing, business outcomes. Gen AI is now on CEOs and boards' agendas as they seek to take the transformational potential of this technology. And I think that's a fair kind of assessment. You know, it is very much at that board level conversations, driving that down into the business to try and find operational efficiencies and new ways of working that will take advantage of the features that are within Gen AI. We offer a semantic retrieval augmentation generation, which is RAG. It delivers answers back that can be trusted because it can deliver them in context of your data. It can be more accurate as a result, and therefore more trustworthy. It leverages the knowledge that is at the human level and applies it to a machine scale. It, like AI when they're being trained, is adaptable. You can improve this using our rules-based approach to tweak the responses that you get back. There are features and functions in the system that allows you to be more compliant within your business and allows you to apply data rules that are held within the platform, but also then that can be passed through to the AI. So you can be sure that the right data is going to the AI. Provide timelines. There's customization within it. There's efficiency gains. There is a competitive edge to the system that we do. Primarily because we are model agnostic. You can use whatever LLM you want. So if there are improvements like the recent GPT 4.0, then you can apply that into your platform. And ultimately, it improves customer/end user experiences because they know that they can trust the answers. They can see the source from where they get to. And Imran's going to cover some of that later on in the talk. So for the agenda today, we're going to talk about why text analytics in particular are a key component of Gen AI. What issues are common with enterprise Gen AI, how text analytics enable more trustworthy and accurate results, how to apply Gen AI and text analytics, including when to combine and when not to combine these technologies, and how AI-driven decision-making is used to provide better business outcomes with our system. If you've got any questions for our panelists today, for Tom or for Imran, then please do use the slide panel there to ask your questions. We'll try to get through to as many of them as we can at the end. We may slightly overrun, and if we do, feel free to catch the on-demand version if you have to leave early. But with all of that out of the way, I'd like to introduce you to Tom Reamy, the Chief Architect for CAPS Group, to talk to you about Gen AI and text analytics. Tom.
Okay, so I'm going to be talking this morning specifically about how to combine text analytics and Gen AI. We're going to start out with talking about the text analytics basics, auto categorization, data extraction, fact extraction, some of the issues around those, and then talk about Gen AI basics and 5 sort of basic flaws that people have identified. And then we're going to talk about combining text analytics and Gen AI to overcome a lot of those flaws, and then talk a little bit about a summary and turn it back over to Imran. Okay, a quick introduction to me. CAPS Group is a company I started back in 2002. It's a network of consultants and partners. We do text analytics consulting primarily. It includes building foundations, applications, taxonomies, etc. We've had a lot of success with what we call a mini POC, where we can take 1 week, get your content, and build auto tagging capability within a week. And that enables you to see it in action. That turns out to be extremely valuable. Okay, we also partner with Progress and a variety of other companies. But we also have clients that we've done projects in all different industries. Pharmaceutical, British Parliament, a lot of government agencies, a lot for the World Bank, and so forth. For more information, you can go and check the website. I'm also the program chair for the Text Analytics Forum, which is a conference that's now in its 8th year. It's coming up in November 2021. So, by the way, if you've already been doing something in text analytics or text analytics and Gen AI, we're still looking for speakers. We got about two weeks left. So check it out by going to the Text Analytics Forum. Lastly, I'm the author of Deep Text, a book on text analytics. And I can safely say that it's the best book on overall text analytics because it's the only book on overall text analytics. There's lots of books about text mining and very specific parts of it, but this is something on how to put the whole thing together within an enterprise. Okay, enough of that. Elements of text analytics. There's lots of different functional areas for text analytics. I'm breaking it down into 3. First is auto categorization, which can be done with statistical approaches, mathematical approaches, or with rules. And as you will hear, I'm a firm believer in rules, because rules basically become the brains of the outfit. They make everything else smarter. Also, it enables you to do sentiment analysis. Sentiment analysis is really just a special case of auto categorization, but you're looking at specific kinds of words. So auto categorization then becomes a platform for multiple applications. Then you've got data extraction, where the software goes in and pulls out entities, organizations, people, dates, what have you, concepts, events, and facts. And that data can then be applied into or ported into analytical applications of all different kinds. One of the standard uses is in enterprise search. You use data extraction to populate facets, and facets are now pretty much standard in enterprise search. and this is a way to populate them easily and accurately. And then there's a whole bunch of supplemental features, NLP, summarization, and a variety of analytical ones. There's also language generation and text mining, which can feed into a whole bunch of applications. So those are sort of the overall basic elements. We're going to talk a little bit more about categorization, because there's really two basic approaches that people have taken. First is machine learning, early AI, using Bayesian statistics, vector space, neural network models. And basically what you do is you generate a training set of documents and then use that to create a statistical or neural net signature, and then compare that signature with new content coming in. It sounds easy. It's actually not all that easy. But in addition, the results are not particularly good. It's difficult to improve them. And you need large numbers of representative documents to get any kind of accuracy at all. I mean, basically, the way to improve it is to give it more documents, and no one's quite sure how that works. So the second way, which is by far, I think, the best, is to use a categorization language. The language can be proprietary. It can be, Python. It can be. There's a number of different ones, but basically they contain operators like Boolean operators, and or and not. But the more important ones are things like near or near within an order, paragraph, and sentence, because this gives you the ability to use the actual existing structural elements of the documents that humans use to understand, but that the sort of bag of words approach that search engines use do not. This gives you much better results. It's much more flexible and it's much more powerful. You can do a whole bunch of different kinds of rules. The rules then can be applied to output of all different kinds. The one drawback is, yes, you need to learn a categorization language. Second point I want to make is, we talked about, people say, the standard, I think it's 80% of business information is unstructured text. Well, the reality is there isn't any such thing as unstructured text. What you have instead is polystructure. Documents are not unstructured. You've got words, sentences, and paragraphs, and we use that to make sense of documents. And if a search engine or AI doesn't use that, the results are not going to be very good. But in addition, you have sections or structures like sections and clusters of co-occurring terms. And those are the ones that are really powerful. So sections can be anything from an abstract to a functional section where it's providing evidence. And by building a content structure model, you can deal with each one of those sections differently. You can, for example, for auto categorization, you can weight words differently depending on the section that they appear in. For categorization, for example, the important sections, of course, are title, subtitle, an abstract, or executive summary. There's also special sections like methods and objectives, which can be used for different kinds of applications. And there's often very systemic text that you actually want to get rid of and not incorporate into most of your applications. And then, of course, there's data sections throughout. Now, the important thing of using something like a summary section or a title section is that it's a human judgment by the author on what the document is about. And it's part of the process of writing the document. So you're not asking authors to add keywords that the search engine can use. We've been doing that for years. The results are horrible. Authors hate it. It's not their job. But writing a summary is part of the process of writing a document. And what we found is that by building rules that take advantage of content structure models, we can routinely improve the accuracy of auto tagging, for example, from 60, that's ranging from 65 to 75% up to 90 to 95%. And that accuracy is extremely important in building applications. This doesn't mean the documents have to be some sort of formal template that every author has to stick their content into. The rules are flexible enough so you can find titles, for example, subtitles, just by where they show up. You can find summaries by looking for certain specific words. Yes, sometimes it's summary or executive summary. Sometimes it's the conclusions or other terms. And the point is that categorization language is flexible enough so that you can grab that no matter what. And in addition, it doesn't have to be, again, like something formal like a summary. For example, in this case, this was a project we did for the Department of Transportation. And what they wanted to do was to figure out what specific work orders were about, what problems caused the work order to be given. Now, work orders can be anything from 3 pages to 300 pages, describing all sorts of aspects of the situation. But what we found is that these 2 sections that are highlighted, those are the only 2 that we really needed to look at in order to really understand what the work orders were for. And so we built rules that did precisely that. Okay, so there we have in 10 minutes or so, text analytics 101. And so now we're going to do the same thing with Gen AI, the basics. Gen AI is a huge leap forward. There's absolutely no doubt about that. I mean, machine learning AI is very good at looking at patterns and numbers. It has never been very good at language. ChatGPT and large language models, suddenly now you can build in the ability to deal with language in a much more advanced way. But basically, ChatGPT is essentially type ahead on steroids. What they're designed to do is predict the next word, and then the next word and the next word and so forth. And it's amazing. We've tried that before, but it hasn't really been all that successful. And because 2 keys were missing. One is scale. Virtually every advance in AI in the last 20 years has been based on increasing the speed and memory capabilities of computers by being able to deal with bigger and bigger scales. The second really key is developing what are called transformers. And those are ways to structure documents into tokens. And tokens are not words, they're just a set number of characters. And you tokenize the document. You then apply a number of different techniques for transforming those into numerical values that capture again, the relationship between the tokens within a particular document. And these are the 2 things that really changed everything, and how ChatGPT became such a revolutionary technology. It does, however, require huge amounts of content and huge neural nets. GPT-4, they won't say exactly how many parameters are in there, but it's rumored that it's about 1.76 trillion parameters. Now, the applications, once you see it, it's truly amazing to see something that will write almost anything. The initial applications are, I think almost everybody's been focusing on customer support chat because that's sort of the standard. But it can write poetry, it can write code, it can write business plans, it can plan your office parties, it can do all sorts of things. One of the early demos I saw from OpenAI, they had it write a poem, but then they changed it to write a poem in which every word begins with Q, and it did a pretty reasonable job. So the point is that this is truly a revolutionary technology, and we're still trying to understand and come to grips with how to make it even more so. But there are some drawbacks. And there's sort of 5 main flaws that we've seen. The biggest one is tendency to hallucinate. You can give it a fantasy world and it will write up something that seems to be as precise as anything that it writes about the real world. It makes up things. And again, it's not that there's a brain behind it saying, I'm going to make up a hallucination. It's just that happens when you try to predict the next word, and those predictions go off track. The second big area is lack of transparency. Nobody knows how this stuff works. You just put it together and it gets better and better. Third is the amount and quality of data needed to train. I did a blog a couple months ago on sort of the AI's weak link, and the weak link is developing training sets that are really good and that can be developed cheaply. I mean, it's one thing to say we're going to go out and scrape the entire internet, and that's good for general purpose, but it's not good for enterprise applications, for example. fourth big area is security issues. All of these companies, OpenAI, Microsoft, Google, they all have rules that they wrap around their GBT so that it won't do things that they want it to do, like tell you how to build a nerve agent or a nuclear bomb. The problem is that people have created what are called jailbreaks, which are prompts in which you get Gen AI to break its own rules. And there's a number of ways of techniques, and of course, it's going to be an ongoing battle between, building the rules and the jailbreaks. But right now, that's a major issue. And the fifth one is really about trying to do this stuff within the enterprise. The problem is things like OpenAI and other large language models are trained on a public vocabulary, and we've known for years that that is not reflective of enterprise language. If your company's doing pharmaceutical research, it's going to have a lot of specialized language. It's going to have a lot of specialized, and so it'll throw off all the predictions based on general public vocabulary. But one of what people are doing primarily is fine-tuning public large language models with enterprise content. The problem is this can be pretty costly, and you have a problem with accuracy in terms of what enterprise content are you going to incorporate into the public large language model. So the limitations primarily around three main areas. One is that if you read anything about Gen AI, you're almost certainly going to run across somebody saying, well, this stuff works the way humans work and the way humans think. No, it doesn't. It mimics human language. There's no real understanding. There's no common sense. There's no notion, for example, of causality. And causality is something that humans use in everything. We actually, there's tests that have shown that people understand a basic kind of causality by age 1. Okay, number 2, when you're using predictions, what you end up with is what's the most likely next word. You're ending up with what's the most popular next word. And popular answers are not necessarily the best. And that's one of the reasons we find a lot of the early writings are fairly superficial and stereotypical writings. Third big limitation is dealing with complexity, complex systems like games. The example that I love is partially because I like to play chess, but there was a project done where they were asking ChatGPT, they gave it like 5 moves, chess moves, and set up a position, and then asked, in this position, there's one move where you can checkmate your opponent. And so they asked GPT, well, should I checkmate this? Should I deliver checkmate on this next move? And it wrote this hilarious, long, involved discussion about, well, maybe you should, maybe you shouldn't, maybe you should try looking at positional issues and tactical issues and whatnot. So no, checkmate is it. If you can deliver checkmate, you win. That's the end of the game. So clearly it does not understand the game. Okay, so those are the pieces, and those are some of the issues. So how do we overcome that? One is putting generative AI and text analytics together. Okay, what do you get by adding text analytics to Gen AI? Accuracy, and that impacts all the attempts to utilize and analyze documents. So how do you do that? One way is to add enterprise vocabulary to large language models. It's called fine-tuning. Again, the problem is that there's a cost of getting good content. You can try statistical methods, but you can get a lot of crap that way, very bad content. In addition, if you try to use human curation, it's pretty expensive, even if you hire low-level people like OpenAI did. Third, search engines, you can't just use a search engine to go and say, find the contents about this or that, because they're not accurate enough right now. So the answer is semi-automatic content creation using auto-categorization and limited human curation. So the basic model is GPT provides a general answer, or in the environment of search, it does the recall stage or a rough draft of a document, and text analytics is the piece that adds precision to that. Okay, how does it do that? In part, it does it with knowledge models. Text analytics can add structure, both conceptual and linguistics, to excuse me, to ChatGPT or GBT. Well, we have multiple types of knowledge organization. There's taxonomies, there's ontologies, there's knowledge graphs are particularly useful in this area. In addition, we have the content structure models that we're talking about, eliminating all the noise you get from bag of words approach to content. And so the important thing to remember is if you're actually thinking about doing the stuff that is based more on the brain than just a simple network, the brain isn't just a network. It's got structural elements that are designed that are focused on specific areas. Like children as young as a month can tell if someone's reading a language backwards rather than forwards, even though they don't know the language yet. So we have these kinds of structural elements in the brain. So if you really want to do something that models the brain, you need these kinds of knowledge structures as well, not just a neural network. Next area is data prep. The way to get good source documents or get good data from text, again, is applying text analytics applications or functionality. And this gives you a much more precise training set. And that's the piece that eliminates an awful lot of hallucinations. Now, in addition, though, when you're trying to put these two pieces together, Gen AI can also provide input into those knowledge models. You get a sort of a draft input into text analytics models, and then in multiple applications and functionality. So Gen AI and text analytics, it's a two-way street. They work together. Another area where they work together is in looking at prompt engineering, a whole new job category that came out over the last couple of years. Well, when you add categorization or data languages like Python or others into prompt engineering, what you can get are prompts that have much greater context and provide GBT much more precise information that it can use. And again, that cuts down on hallucinations. So how does all that work in an enterprise? We're going to go through this fairly quickly. Basically, you've got a number of layers. You've got the content layer, the actual content itself, the text, which actually can also include metadata. You've got the conceptual layer with the taxonomies and knowledge graphs and so forth. And then the text analytics layer that does the data extraction, auto categorization. That then works on the output of all of the above and creates structured data or tagged content or the enterprise large language model component that you can use to fine tune the public large language model. All that comes together, and you then create business value by creating all of these different kinds of applications: search, KM, fraud detection, topic discovery, and so forth. Okay, so when do you use both? When do you use text analytics, AI, or both? The key is that Gen AI is probabilistic, and it depends on the prompt. If you have a different prompt, you're going to get a different answer. If your word is slightly different, you're going to get a different answer. So the point is that if you need precision, and you don't necessarily need precision, for example, if you're using it to write a rough draft of a document. But in other cases where you do need precision, then the answer is to either use text analytics by itself, or in this case, probably better is a combination of text analytics and Gen AI. An example of that is enterprise search. RAG, retrieval augmented generation, is a really great technique that's been developed fairly recently, which is a combination of answers that the ChatGPT gives you or GBT gives you, and the links that a normal search engine would give you. Then the key is that gets put back into the system, and you incorporate the answer and the links together, creating a new context, which then provides much better and much more accurate results. And again, it's a great technique for eliminating hallucinations. And it also finally gives an enterprise search that users will love, which we know they haven't over many years. Okay, so in general then, and this is one of the things I've tried to do today, is sort of, this first part is to give you a broad context about all of this, and then we're going to get more into specifics in a little bit. Okay, so in conclusion, Gen AI really is a major advance for AI. It adds language capability, but it is limited with these 5 flaws. There's still a bit of a struggle to find enterprise applications beyond customer support, and poor accuracy is the main culprit behind that. Text analytics, or semantic AI is another word for it, adds accuracy, depth, and application platform. So what does that development and application platform look like? It looks like Progress's data platform, and that's what we're going to hear about next. Thank you.
Thank you, Tom. And let's just roll right into the platform here. So one thing to note is that there's a lot of different areas in pretty much any business where the landscape is changing, new regulations, new ways of monetizing things, generative AI is creating new applications. So all of these things means that a lot of your world from an IT or technology perspective is changing all the time. And the Progress Data Platform can help you handle this change in a semi-controlled manner, shall we say. Also, Gartner noted that 55% of companies are now either piloting or are in production. And also the same percentage of companies are thinking about AI first in terms of new applications or new technologies to apply to problems. So the problem statement that Tom really accurately described, pun intended here, is how do we improve the trust and the accuracy of Gen AI responses, especially if we don't want to create our own models or adjust our models, which have significant cost and privacy concerns. So we looked at 3 different architectures. The first one was a closed book exam, essentially, where you train the Gen AI for years, you ask it a question, and then it spends time through its neural network to try to figure out the best set of words, and it tries to answer it. And this has all of the problems that Tom had already talked about, so we'll just skip by the problem list here. Then the second architecture that we looked at is a RAG architecture, retrieval augmented generation architecture. And in this case, we were worried about just getting the right sort of page of a book over to the Gen AI, depending on the question being asked. And so the process here is to take in your content, to chop it up into document sections. Why document sections? Because you need to squeeze it into the Gen AI's attentions token window. And then you can take the user's query and based on the user's query, try to determine the highest relevancy words based on what we know about the content. And then go ahead and do that search. That might give you 50 documents, out of which you might pick the top 5 or 10, depending on how big the context window is. And then you have the Gen AI answer that. So that's better than just not having RAG, but the context is still somewhat, shall we say, open to interpretation or not as tight as it can be. And that's where text analytics and semantics comes into play. And that's the third architecture that we used. And we in this architecture, we basically had Semaphore, which is a knowledge capture graph governance tool that can do more than just capturing the graph and governing it. It can also do categorization and fact extraction. And in fact, those are the things we take full advantage of. So this is kind of like having an open book exam, but the teaching assistant is sitting right next to you, and you're free to ask the teaching assistant questions that might make sense to you. So again, step 1 is the same, but then step 2 is slightly different. What we're going to do when we're bringing the content in is we're going to categorize the content based on the enterprise knowledge that we've created. We can also fact extract data from that content. And once you have that, then you can take the user's query. And again, with the graph, you can decide, oh, here's the concepts in the user's query that we know about that are important. And you can prioritize those during your search, in addition to the normal search parameters that you have in a regular search engine. And then you can get, say, your top 50 answers again, like before. But now, let's say those top 50 answers have maybe 5,000 sentences in them. You can further filter the content even further, again, with the knowledge that you've got, to reduce that to maybe the top 900 sentences or something like that. And then feed that into the generative AI with the prompt engineering that Tom talked about. And then once you've done that, you'll get an answer. And even in the answer, you can prompt engineer to say, hey, if you use any of the content we gave you, please provide URLs back to that content so that people can examine that content and determine the validity of the answer, thereby allowing people to check for hallucinations by themselves. Another way to automate that hallucination checking is to look for semantic knowledge in the graph itself, and you can say, hey, if certain percentage of the content doesn't have semantic knowledge that we know about, for this, we might want to say, this is probably not a good answer, and automatically ask the Gen AI to review and correct the answer based on what we know about the graph, right? So there's a lot of things you can do with a semantic graph once you have it. And now, without further ado, we went ahead and then said, let's just go and test drive these three architectures. And the example use case we did was, let's pretend to be a healthcare insurance company with benefit coverage plan documents. And there's lots of questions people ask in healthcare for their own treatments and conditions, and prior authorizations and coverages. And so we first asked a very general question: what is CGM? And that stands for continuous glucose monitoring. And all three architectures, right? No RAG, RAG without semantics or text analytics built into it, and then RAG with semantics built into it. All three answered the question pretty well. So we did this for I'd say 5 or 6 different general questions, and all three were good. But then we said, all right, let's start pushing it to the point where the out of the box one starts breaking because it doesn't know the answer to the question, because maybe that answer was not in its training data set, or was not didn't occur often enough in its training data set, and so on, right? So we came up with this question: list all the billing codes for CGM along with a brief description of those codes. This is something a biller would totally want to do in a plan system. And the out of the box says, hey, I'm not really sure. Should I fetch some for you? And I pushed it and said, yep, go for it. And it gave me a few, but then it stopped again and said, hey, do you want me to look for more? And at that point, I'm like, okay, enough, because you're not sure that you're going to be able to retrieve all of them. With the private data, it was able to just say, oh, yeah, I know which section of the document that's in. Let me just pull that chunk out and start spitting it back out to the user. And with the semantic one, because it was given to it in semantic sets, sentences, full sentences, it kind of did the same thing and formatted it a little more nicely in terms of full sentences. So then we asked an even more interesting question: does the make believe Acme Insurance Company pay for CGM? And the out of the box one, thankfully enough, didn't hallucinate, but it did say, hey, I don't know, go check with Acme Insurance Company. They might be able to tell you something. The Gen AI, the private data one, said, oh, sure, it does, but you have to meet certain coverages. And then the semantic one gave more and articulated more details on the coverages. And then the idea on the semantic side is, if you have a semantic graph, you can look at the concepts in the returned document and you can create hot links. And so for this one, if I were to click on this kind of a hot link, it would take me back to the reference model that an end user could explore. And they might look at alternative labels and go, you're missing an acronym here that would be useful to know about. And so they can provide feedback into the system and not have to be an expert in the model, but still be able to provide crowdsourced feedback into the system very easily. So we also thought a little bit, actually a lot, about what does it take to be a good long-term memory system for generative AI systems? And it's a combination of things. You need a database, but the database should be able to handle all different kinds of data. It shouldn't just be structured elements. It shouldn't just be PowerPoints. It shouldn't just be PDF files, right? It can be anything and everything that your enterprise generates. It needs to have security, right? It needs to be able to lock down the content because certain pieces of content are only available to certain employees and so on. But then you combine it with text analytics and knowledge graphs to get that semantic understanding of the world. And that's really what the Progress Data Platform can bring to the table here. In particular, the two pieces of the puzzle from Progress's side that have been doing sort of the heavy lifting in the platform with respect to generative AI is sort of this multi-model store anything database, search anything database, and then the ability to capture and create business graphs, to use those graphs to enrich, in fact, extract the content. And that really gives you more improved results, increased trustworthiness, and because the database itself can store the questions and answers and do all sorts of other operational things in a Gen AI solution, you can get a pretty hefty set of cost savings as well. All right, and we just covered this, so it's just hammering home that with our solution we can really improve AI trustworthiness. The other thing to think about from a long-term memory perspective is what are the characteristics that make a long-term memory extremely valuable to a Gen AI platform? First of all, it needs to be real time so that you don't have this data cutoff problem that Gen AI systems typically have. So being able to update your content and being able to retrieve the latest version of that content as opposed to older versions is really important. The idea that when our human brains try to recall memory and try to think about things, they're trying to pull back sort of the most semantically relevant content that needs to be there. If we make it human readable, it's great for governance, it's great for debugging, it's great for understanding, and sort of making a white box system out of what is generally a black box scenario. And then the ability to switch models. Tom was just, I think I was just actually at a talk this morning where they were saying, oh, and on the flight over here, Gen AI, OpenAI just released a new model, right? So being able to switch out models at will, being able to use multiple models at will against your data is really important. The ability to understand who your user is and tune what you give to the Gen AI based on the user. Like a biller will want stuff different from a provider or a regular end user, right? Those sorts of things. Also, the ability to tie security to the roles of the user are very important. And then governance and data quality and being able to rapidly integrate multiple content from multiple silos is also extremely important in building out a good long-term data platform for your Gen AI solutions. Really, what we're saying is Gen AI is great, but you really want to be able to combine semantics and text analytics that are human governed and understood to get the best of both worlds. And that really delivers a lot of business benefits, as you can see in this slide. The biggest ones that I feel should really turn heads is accuracy. Creating inferencing and generating new content based on sort of a question is a very expensive proposition. And if you can get it right the first time instead of the 10th time, everybody's done some chatting with ChatGPT and knows you might have to refine the ChatGPT's response a lot of different times before you get the answer that you're interested in. And so that's one really interesting one. On the efficiency side, the ability to really drive down costs by reducing the amount of vectorization that has to happen, reducing the amount of searching that has to happen, the ability to cache answers, things like that. Those all give you some really interesting benefits, and all of these other benefits are of course very much helpful for companies to gain competitive edges and to actually succeed in your Gen AI solutions and projects. So the key takeaway is if you bring in garbage, you're going to get garbage out. Accuracy and hallucination is really important thing to solve for, and being able to provide and translate and reuse human knowledge across the enterprise in a very reliable, repeatable fashion is extremely important. And now we'll be going back to questions, and I will hand it off to Phil.
Perfect. Cheers, Imran. Let me just turn on my camera there. Thank you for that. Thank you for our speakers and the questions that we've got throughout the thing. So if you guys want to switch on your cameras, I think we were also joined by Steve Ingram. He's our senior manager for sales engineering in Semaphore. He's got a wealth of experience there to answer some of the questions that have come through. It's really good to see that combination of that text analytics approach and seeing how that can apply in a Gen AI world. One thing you did mention, Tom, I think in your presentation, and it was one of the questions from the customer, but what is the sort of time and resource commitment from a customer's perspective for the mini POC that you were talking about?
Okay, excuse me. Well, it can, of course, vary considerably. In some cases, actually, it almost requires almost nothing. But more typical would be for the client, the customer, to have a contact person to provide input into selecting 10 categories from their taxonomy, or just 10 categories, and then subject matter experts to select 10 documents that are good examples for each one. And that's pretty much it, except at the end, then there's, of course, the time to review and evaluate. So it's very, very minimal amount of time and resources from the customer.
I'm sure people will be glad to hear about that. Please do keep your questions coming through, but we've got one for Steve here, and that's why I kind of tapped him on the shoulder to bring him in at the last minute. But you mentioned knowledge models. What's the difference between knowledge models and taxonomies and ontologies? What's the differences between those things?
I might risk offending an information scientist, but from our perspective, there's really no difference. It's why we use the phrase knowledge model, because a taxonomy is strictly hierarchical. So if you have associative relationships going across, which inevitably you will do, they don't fit easily into a taxonomy. An ontology has the classes and the relationships, but where you might say we have a medical condition and a treatment, you actually need to have what are the treatments, what are the medical conditions, what are the relationships between the two. So we can manage all of them using Semaphore and take advantage of whatever you have, even if all you have is just a straight list of controlled vocabulary. It's all managed the same way.
Yeah, and it's really kind of taking the business expertise and the data that's within your data, and I think combining those two is really effective. You've got a lot of knowledge in your business about how you yourself describe the business, so being able to apply that at scale is really interesting. Tom, can you explain the process of integrating text analytics and Gen AI into existing systems and workflows?
Sure. I mean, the main thing to keep in mind is that text analytics and Gen AI as well, they shouldn't be thought of as specific applications, but rather they're part of your semantic infrastructure of your platform for building a whole range of applications. So, for example, if you want to build a business intelligence application, text analytics then it can be incorporated into that at different stages of the process. Number one is it can do pre-processing of the content. You feed it content and metadata and so forth. That can then be incorporated into the large language model is one avenue in, or it can be incorporated into the Gen AI prompt. And once it's incorporated into the Gen AI prompt, then the text analytics can be applied to the output, and so it adds another step to refining the results from the Gen AI. And that's pretty much the basic model. It's like text analytics it can be incorporated into applications at the infrastructure level, into the large language model, or it can be applied into the actual application, into the prompt, like to incorporate into a RAG application.
Yeah, I think that's a really important point to make, is that you're not just applying this RAG-based text analytics technology to the prompt, but you can also apply it to the response as well. And that's the key to identifying the correct data, the lack of hallucinations. You can see that when you search against the response in your knowledge model. So Imran, we said about the human in the loop, but what role does the human play in the development and the deployment of text analytics and Gen AI?
Yeah, so pre-Gen AI systems, I would say, can you guys hear me?
Yeah.
Okay. So pre-Gen AI systems, I would say that it was a reasonably heavy lift in terms of humans would be writing the whole graph and all of the relationships and vetting everything individually. With Gen AI now, you can use the Gen AI to rapidly create a set of candidate semantic nodes, as well as semantic relationships that you can review and include or not include. So that's helped a lot in terms of the speed at which corporations can now generate those graphs. We've just started working on this new feature, new architecture, actually, we'll call it, which we're calling it progressive graphs, where we use the Gen AI to potentially discover and put in new concepts into Semaphore's knowledge review tool that can then be rapidly incorporated or not incorporated by, again, the human in the loop.
And a question that's just come in for Steve, and I know you might have answered the individual, but I just want to get that out there as well, is can we say that Semaphore supports ontologies defined in languages such as OWL to create a knowledge base?
Yep. So we can support OWL. We can support, even if you've got OWL, great. That's a really good, rich resource. If you just have a spreadsheet of terms, we can use that as well. We can import both of those. There's usually a little bit of work done with an OWL ontology, but absolutely we can use OWL definitions.
Yeah, I think the great thing is once they're in Semaphore, they're a lot easier to manage and attribute and to change classifications and things like that by using the knowledge management tool as well as other tools in the platform. So it gives a really good UI for non-technical users, let's say, such as myself.
And we also we also preserve the OWL triples. So if you import it into Semaphore, you export it. We haven't damaged anything; it's all still there.
Yeah, great for transparency and trust there. Imran, can you elaborate, should I say, on the scalability of Gen AI, especially when working with large volumes of unstructured data?
Sure. So in the RAG architecture, you really want to find and retrieve the right pieces of content, and storing that content either completely in MarkLogic or just the text of it so that it's discoverable and findable is an option. So you can scale by storing just metadata in MarkLogic or by storing the full data sets. And we have a shared nothing architecture, so that really lets you scale by just adding more compute nodes as you need to. And our customers are in the petabyte range, some of our larger ones, across multiple clusters that they use.
Yeah, and I guess there's more and more advances in Gen AI as well, where they're expanding their token windows. I think, what was it? Gemini said there was 2 million tokens now, I think, in their context window. So they're only getting larger and larger. So yeah, really interesting. And I guess, how do you ensure like transparency and lineage in solutions when working with especially sensitive data, like in the healthcare space with PII and things like that?
Right. So we have a universal index that incorporates security. That security has role-based security tied into it, so that individual documents are tied to roles, so that when a person comes in, let's say he's from Europe and he has access to European customers, but a US person doesn't, the ability to sort of hide the European customers from the US person is very easy to do in our systems. Also, the role-based security goes down not only to documents, but individual elements within documents. So you could have this section is sensitive and the rest of the stuff is a fair game for analysis by a broader group. The other thing is because we store stuff in a tree-like architecture, so typically it's either XML or JSON is the underlying document structure. We can store a lot of provenance and governance information into that tree along with the actual content or data. And that gives us another sort of way of securing the system, and it's called query-based access control. So we can actually use the content itself, which could be metadata about the data, to decide whether this data should be visible or not.
Yeah, and I guess, Steve, as well, I mean, Semaphore has a number of features that help in this space. I believe you can identify PII information or help with the identification of PII.
So, yeah, the NLP engine can pick up PII, the number of entities it picks up, but also you can model more complicated structures. So if you're looking at export control, you may want to lock off part of your content to particular audiences or people only logging in from certain locations. And that can be done using any of the definitions that you can classify for.
Yeah, and I think that's really interesting because you can do the reverse. So, and correct me if I'm wrong, I'm going to put this idea out there, you might not have heard it yet, but there's a problem with Gen AI where it will generate information about an individual that might be incorrect. In fact, there are some notable examples of where some solutions are being sued in that respect. Could you, for instance, get the response back from the Gen AI and kind of intercept that before it goes to the user to say, does this have any PII information in it? If it does, we shouldn't be showing this. Is that possible at all?
Yeah, definitely possible.
It's just
classic use of text analytics. Yes, absolutely.
Yep.
Yeah, I just think it's a consideration. I think people think about the data going in, but not necessarily the data coming out. So I thought that was an interesting use case for that. Well, we're coming up to the top of the hour. I think we've covered most of the questions. If we haven't got to yourself, or if you've got a question that you want to ask, but can't bring yourself to type it in, then please do reach out to us. We're more than willing to talk to you in more detail, show you demos of these things working, and how this might work in your organization. Thank you to Tom. Tom's books are available. They're in the chat now. The link, both links for the ebook and the physical copy are both in the chat. We've also got an ebook on the solution that Imran presented on. Yes, so thank you all to everyone that's joined us today, and we look forward to seeing you again soon. Cheers, guys. Thank you very much.
Thank you.
Thank you.
Thank you.